Welcome back to Algebra 1. Please pause the video and solve these using order of operations. So when doing order of operations, I'm always looking at what steps I need to do first. These particular parentheses really don't stand for parentheses. They're just in holding a negative sign in place. So I'm not doing anything with parentheses. I don't have any exponents. My first thing I'm going to do from left to right, all multiplication or division. And the first thing I run into is division. So this part here becomes a -7, but then since I am subtracting it, it'll be positive. Then I have 17 plus 7 plus a negative, so that's going to be -1, and that ends up with 23. Over here, I have two types of parentheses. The first one is the parentheses on the inside, and then the second one is the brackets are also acting as parentheses, and 8 times 15 is 120. Then I'm going to multiply that by the 3, so this has now become times, and times happens before subtraction. So then I have 360, that's a negative, so I have -1 minus 360, and that's a 60, not a 0. Okay, giving me a -361. Here I do have parentheses and brackets. I'm going to do the parentheses inside first. Then I do the bracket. 13 minus 8 is 5. I do have an exponent out here, so I'm going to go ahead and do that. Then I'm going to do from left to right, all multiplication and division. So 97 times 1 times 5 is going to get me 485. Then I'm going to subtract 8 from that, and I get 477. In this last one, I have parentheses, but I can't do inside these parentheses until I do the exponent. But 1 to the 4th power is 1. 10 times that is going to be 11. 17 times 11 is going to be 187. Minus a -4 becomes +4, and that's where we get 191. We are now going to solve using something that works all the time. It's a little bit of a long equation, but it does work. It's called the quadratic formula. And the quadratic formula is based on everything being on one side of the problem and it being equal to 0. Once I have it in standard form like this, the number in front of the x squared is called a, the number in front of the x is called b, and the constant is called c. Those are plugged into this equation here. And I do like to start with what I refer to as the fill-in-the-blank form of the equation, because I'm going to keep track of all the pluses and minuses and squares and all of those things. I'm just going to make a fewer mistakes if I start with this format. The parentheses are very important. So one of the ways that I can set this up is I need a place for my equation. I do want to see the actual form of the equation, and I have my fill-in-the-blank form here. I am going to pull out what is A, what is B. B is actually -5, not +5. I am going to keep all of the signs with my problems. And C is 3. Those things are going to go into my fill-in-the-blank form of the equation. Negative what? This first spot is a b, so I'm going to plug in -5. Plus or minus square root, my next one is also b. Then I next run into a and c. So a is 2 here, c is 3, and in the denominator I have a again. Once I set up those things and I do all the substitution, I'm going to get rid of a whole bunch of parentheses, actually all of them, by cleaning things up. And I'm going to clean up 4 spots. I'm going to clean up my first term here. Minus a negative becomes positive 5. I'm going to keep the plus minus, and I'm going to keep the square root, and I'm going to write it large enough to put 2 things underneath. Sometimes I will switch down to the bottom and clean that up real quick. Notice it goes under the entire thing. Then inside, this parentheses is very important because negative 5 times negative 5, this term will always be a positive. Then I'm going to subtract, and I get 4 times 2 times 3 is going to be 24. My next step is I clean up underneath the square root sign. So I add, subtract as I see, and I get the square root of 1. But I know the square root of 1. It's 1. So because I know it, I take it out of the square root sign. Now, there are 2 problems in here, 2 solutions. The first one is going to be 5 plus 1 divided by 4, and that's going to be 6 over 4, which is 3 over 2. Please get used to leaving solutions as fractions. Then I can also do 5 minus 1 divided by 4. That's 4 over 4. So my solution is 1. So I have my 2 solutions here. Now, you can set them up this way every time. I'm not always going to write all this out, but it's the same idea. So I start with my problem in standard form. Do notice that it says I'm going to round to the nearest tenth, and the very first step is what is A, what is B, and what is C. If I do not see a number in front of the term, it's got to be a 1. B is negative 6, and C is 5. Make sure you keep all of the signs with the terms. Then as I start filling in, and you're going to look at your notes to see where A, B, and C are in the equation. This first one is B. The second one is B. I have 2 places that I'm going to look for A. That's going to be here and here. And C is 5. So I clean up 4 spots in this equation. First one, minus a negative 6 is plus 6. Plus and minus, square root large enough for 2 terms, and underneath 2 times 1 is 2. Inside, negative 6 squared is 36, positive 36, minus, and 4 times 1 times 5 is 20. So underneath the square root sign is the next thing I clean up, and that is 16. Well, the square root of 16, I happen to know it is 4. So this is going to tell me to do 2 different things. Do make sure you do the top step first. So I have 6 plus 4, then divide by 2. That's going to be 10 divided by 2, which is 5. Then I also have 6 minus 4 divided by 2. 2 divided by 2 is 1. There are my 2 solutions. I could have solved this by factoring, which would have been much faster. Not everything factors. So for my next problem, it is in standard form. Very first step, what is A? A is a half. A will clean up. Keep it as a fraction for a little while. B is 1. And C is negative 10. It is important that we keep the sign. So filling in the blanks, B goes in 2 spots. B goes first and the second set of parentheses. A is going to go in this spot here. Well, I can do a half of 4, and I can do a half of 2. So I'm going to be able to clean those up pretty easily. And here we get negative 10. So remember, we're cleaning up the 4 spots. First term, this time it's going to be a negative. Plus or minus, long enough for 2 numbers, 1 squared. Now be careful. Minus 4 times positive times a negative. This ends up being plus. Half of 4 is 2. 2 times 10 is 20. And 2 times a half gets me 1. So now, when I clean up what's underneath the square root sign, I get the square root of 21. And that's not a perfect square. So I am going to grab a calculator and clean that up. I know I'm expecting it to be between 4 and 5. And since they want it rounded to the nearest tenth, it is 4.6. I'm not going to keep putting over 1 because anything divided by 1 is itself, but I am going to have to do the top of this, and that's going to be 3.6, and the bottom of this, negative 1 minus 4.6, is negative 5.6. So we have 2 solutions to our problem. Next problem is also in standard form, and we're going to do A is negative 3, B is 2, and C is 7. And I know that this position is C. My 2 things that are B are here and here. And A so then I'm going to clean up my 4 positions. Negative 2 has to stay negative. The 2 things underneath the square root sign are going to be 4. Minus times a negative times a positive is plus. 12 times 7 is 84. And negative 6. Now this one says something a little bit differently. It says find the exact solution. The first ones that you do, you're going to be rounding, and then you're going to start simplifying and finding exact solutions. And the thing that changes is once I have a square root, I am not going to grab a calculator. I am going to look for the perfect square root. What we did on the worksheet on perfect squares. I notice that this is divisible by 4. So this becomes the square root of 4 times the square root of 22. That was just an extra scribble there, it doesn't mean anything. And I know the square root of 4 is 2, and I don't know the square root of 22, and it doesn't have any other perfect squares in it. So when I come over here, I get 2 times the square root of 22, and it's over negative 6. Now this negative 6 has to go into all of the part terms on top. And so I'm going to clean both of these guys up. I could write it as 2 separate terms with the denominator being negative 6. This is perfectly valid. Now what happens when I have a negative divided by a negative? It becomes positive, so this could be just 1/3. If I have a plus and I divide it by a negative, I get negative. And if I have a minus and divide it by a negative, I get positive. So when I have this symbol here, this negative sign isn't going to be important to me. This 2 goes into this 6 3 times, and I end up with the square root of 22 over 3. That is an exact answer. Now another way that we could write that without putting it under both terms would be 1 plus or minus the square root of 22 over 3. Both of those ways to write it are perfectly valid. Our problem is not in standard form, so the first step is to write it that way. And I need to move this 1 over, so that's going to be 4x squared minus 4x, and it's going to be plus 1. It's important that I get the right signs on things. A, again, A is going to be 4, and I do know that A goes here and here. B is a negative 4. That will be important here. And negative times a negative will be a positive. And my last term, C, is now positive 1 right here. So when I clean up my 4 different spots on here, minus a negative 4 is positive 4. 2 times 4, that's going to be 8, plus or minus, square root large enough for 2 terms. Negative 4 squared, that's 16, minus, all positive, so it will be minus 4 times 4 times 1, 16. Underneath the square root sign, we now have 0. And the square root of 0 is 0. And adding or subtracting 0 to a number doesn't change it. So I'm going to have 4 over 8, and always simplify fractions. This is the type of problem that has only one solution. Okay, we can also solve problems that are word problems. In this particular case, we're looking for when they're going to have 35 breeding pairs of wolves in this case. And you notice that I'm kind of estimating if I look for 35, so I'm not really sure if it's 10 or 11, it's somewhere around there. What I do with my problem is 35 is my y, and the rest of the problem does not change. So in order to get this in standard form, I need to move the 35 to the other side. So now that I have 0 equals, I'm ready to use the quadratic formula, recognizing that A So A here is 0.2. I'm going to go ahead and put that here. The next 0 does not change the accuracy of the term. Then I have B. B is 1.8. And don't know 1.8 squared offhand, so we're going to grab a calculator. And C is negative 38, and that will go here. So 2 of these aren't too bad, but we'll grab a calculator at parts. Now remember, when we get to word problems, there's often a solution that's not really going to make sense to us, because we had a starting time of 0. So 1.8 squared is 3.24. Minus times positive times negative is going to be plus. And it's 30.4. So underneath the square root sign, we have 33.64. And that is a, grab the calculator, square root of that. Is 5.8. So I am negative 1.8 plus or minus 5.8. But if I subtract 5.8 from a number that's already negative, I'm going to get a negative number that's not in the range of my graph. So I'm actually just going to do the positive one. And I have to do the numerator first. That becomes 4 divided by 0.4 is 10. And in this case, it is years. Since 1990, so 10 years after 1990 would be in the year 2000. Lastly, sometimes they give me a y, and sometimes they're asking me about x. In this first problem here, when we have bald eagle nesting pairs, and we're looking for when there will be 160, that is our y, we're going to set it up exactly like we did the last problem. 160 equals the equation, solve it for 0, use the quadratic. If I'm looking for how many bald eagle nesting pairs there were in 2000, I have to think of what year 2000 is. And 2000 is the beginning of our study, and x would equal 0. When we plug 0 into the equation, 0 times anything is 0, 0 times anything is 0, and we would be left with the starting number of pairs is 51. We could also have asked for a different year as well. Your homework is on Google Classroom, and have a good day.